calculator technique for second derivative. But before we proceed, we need to understand why we need to learn second derivative calculator technique. So it is very important because when we are given complex functions such as functions that include trigonometry, hyperbolic functions, and even a mix of logarithmic and exponential functions, it will be very difficult for us to manually solve. It will be time consuming for us to check the second derivative. Thus, we need to use this calculator technique. And what we need to always remember is that we need to set our calculators into radian mode, when especially if our function that we are be deriving is, it contains trigonometry and hyperbolic functions. So this is the problem. Evaluate the second derivative of the function y equals x ln x. Okay, so this is just for simplicity. We need to have a simple function so we can derive it easily, and we can show you the calculator technique in simple terms. Okay, so this is our function. So in calculating the second derivative, of course, we need to have the first derivative first. Okay, so d over dx, or we need to differentiate the function in terms of the variable x. So our y prime, or the dy over dx, will become, we need to use the product rule. So x and the derivative of ln x is 1 over x plus ln x and the derivative of x, which is 1. And we simplify, then we get the first derivative. We have y prime equals 1 plus ln x. And then this derived function, we need to differentiate it again. So differentiate in terms of x. So this constant becomes 0, and the derivative of ln x is 1 over x. So therefore, our second derivative is 1 over x. So again, this is just for simplicity. We used a simple function. But here is the calculator technique, or we need to check if this 1 over x is correct. So the very first step is that we input the given function to our calculator. This x ln x. So this is the step 1. So find d over dx in your calculator. So this one. And then input the function x ln x. And then set x equals 0.1. Okay. And then the answer, you need to store it to the variable a. This one. So shift store a, and then press AC. Okay. Second step is you need to differentiate again, but this time we need to add a very small change, which is, we have also tackled this in limits, is 1 times 10 raised to negative 5. Okay, we input the function again here in the first derivative. So x ln x, but this time instead of 0.1, we need to add this change, 1 times 10 raised to negative 5. And then the answer for this, you need to store it to the variable b. Shift store b, and then press AC. Let's check. Okay, so the second step is that we need to differentiate again. So we need to input our function, but this time we need to have a very small change, which is, we have already tackled this in limits, this 1 times 10 raised to negative 5. So input the function again in the first derivative of your calculator. So x ln of x 0.1. So this time we need to add a small change, which is this 1 times 10 raised to negative 5 equals. And then the answer is, you need to store it to the variable b. Shift store b, and then press AC. Okay, so you have already the values for a and b. So the third step is that you calculate for the second derivative, this one, the y double prime. So in calculating the y double prime, we need to have this formula, b minus a over 1 times 10 raised to negative 5, and then store it to c. Okay, we need to recall b minus a divided by 1 times 10 raised to negative 5. Okay, so the answer for this, you need to store it to C. Shift, store, C. This one. Okay. So the fourth step is that you calc your answer, your manual answer. So in this case, we have y double prime, this one, equals 1 over x. And then set x equals 0.1, depending on what value you have put here. Okay, so 1 over x calc 0.1 equals 10, and then store it to D, this one. Okay, to check if your manual answer is correct or your second derivative is correct, so we need to proceed to the final step, which is we need to divide C and D. If it will equate to 1, then your answer is correct. Okay, so C divided by D. Again, if it will result to 1, then you got the correct answer. Okay, so we have 0.9999 or approximately equal to 1. Thus, your answer is correct. Okay, so that is our second derivative calculator technique, and on the next video, I will show the calculator technique for the third derivative. So stay tuned and follow for more.